Hello everyone, today we're going to be doing Module 5, Lesson 30. Our objective is I can add a mixed number and a fraction. Yesterday we worked with estimation in adding mixed numbers and fractions. Today we're going to be moving towards methods for how to actually do that addition. And we're mostly going to be focusing on unit form, which we'll talk about a little bit later. Our first activity in a normal class would be doing a sprint. We're going to treat this sprint as a little bit of like a fast practice at home. It'll be uploaded to Google Classroom for you to do at home. The next thing we're going to do is talk about comparing fractions. So using our estimation skills, we can figure out where these numbers kind of sit in relation to each other. So for instance, if I have 5/19, I know that 5 goes into 19 3 times. When I get 3 5s, I have 15. And to get from 15 to 19, I have 4/5. And 3 goes into 12 4 times. Just by using what I know about multiples, without actually being able to find the fraction, I can figure out the answer. So 4 goes into 25 6 times. And 5 goes into 24 times. I'm going to pause now in case you want to do the other 4 on your own. Okay, so now 4 goes into 25, like we said, 6 times. Remember, I'm using estimation to just benchmark, knowing the multiples. So in my head, I'm going 4, 8, 12, 16, 20, 24. On this side, I'm doing multiples of 5 because that's my denominator. 5, 10, 15, 20, 25. So 5. I know this one's bigger. 3 goes into 26. 3, 6, 9, 12, 15, 18, 21, 24. 8 times. And 4 goes into 32. 8 times. So here's one where I'd want to actually find the mixed number. Knowing that 3 goes into 26, 3 times 8 is 24. So this one has 2/3 left over. It's a little bit bigger than 8. 2 goes into 17, 8 times. 3 goes into 19, 6 times. Okay, now let's look at the actual problems for today. So if I rewrite this expression using unit form, that can help us solve fraction addition problems. And by unit form, I mean we're going to look at the ones and the denominator, the fraction. So if I rewrite this expression right here in the unit form, I have 2 ones, 3/8 plus 3/8. Now think to yourself, what units do you see that are involved with this problem? Right, so our units are ones and eighths. And it's just to help us see that a little bit more clearly, I'm going to highlight that. Ones and eighths. So those words are our units. Ones and eighths. Just like before with any fractions, when we add numbers, especially fractions, we add like units. So to show that, we have, I'm going to rewrite that down here. 2 ones, 3/8 plus 3/8. I start with the ones first, so I end up with, there's no other ones, so I just have 2 ones. But because these two are similar, I need to add them together. So the eighths will stay, but the 3 plus 3 makes 6/8. To show that addition using a number line, my answer, I know already that it's going to be between 2, and since it's more than 2, between 2 and 3. So on my number line, I'm going to have my endpoints be 2 and 3. And to make eighths, remember I just split it down the middle to make halves. Half of a half is a fourth. Half of my fourths are eighths. So this is 2 3/8 right here, 2 3/8. And then when I add, so this is my starting number. Then when I add 3/8, 1, 2, 3. And this is actually the addition part. Add 3/8. I get 2 6/8. And that should match, right? 1, 2, 3, 4, 5, 6. When we add 3 plus 3, it should be 6. Okay, let's try it with another problem. I have 2 3/8 plus 5/8. If I rewrite this and I add like units, I have 2 1s, 3/8 plus 5/8 equals 2 1s and 8/8. If this number and the unit match, that's the same as 1, so this is kind of like 2 plus 1, so it's the same as 3. To show that using a number line, my endpoints are going to be 2 and 3. I start with 2 because 2 3/8, 2 is the whole number in that part. So I have my 2, and I have my 3, because I know that's going to be the answer. In the middle, I have my half. If I split my halves in half, I have a fourth. Split that one more time, I have eighths. I start at 2 3/8. Last time I showed an arrow to show that we're getting to 3/8. Usually we want to show the arrow just for addition, but I wanted to show how those were related. This time I'm just going to start with the number. That's my starting number. I'm going to add 5/8. 1, 2, 3, 4, 5. I'm going to use the arrow this time to show addition, and that's plus 5/8, and I get to my 3 right there. So when we add 5/8 more, it makes a new unit of 1, a new whole number, 3. So those fractional units, 3/8 plus 5/8, like we said before, if I have 8/8, we've seen this before, if I have 8/8, that equals 1. So if 5 plus 3 make 8, then that has to be a 1 that I add on to that original 2. Okay, let's look at another problem. Just to start off with, to add fractional units, sometimes we complete a unit of 1, like we just did with that last problem. We look for fractions that have a sum of 1. If we can make the numerator and the denominator match, that's a really great way to kind of make a fraction addition problem easier. 1s are kind of the easiest numbers to work with, other than maybe a 0. So if a fraction is equal to 1, what do we know about the numerator and the denominator? So I'll use this as an example. What do you notice about this? Okay, right, the numerator is the same or equal to the denominator. Once those are the same, we know we have 1. So if I have 1/4, how much more do I need to make 1? Pause here and think to yourself. If I have 1/4, how much more do I need? 3, 2, 1. I need 3/4. If I have 3/8, how much more do I need? Think to yourself. I'm going to pause here. Okay, come back together in 3, 2, 1. 3, it's kind of like saying 3 plus what makes 8 for that top. You know that's 5. So 5/8 is what I need. The unit on the bottom always stays the same. That's why I can kind of treat the top as its own addition problem. Okay, if I have 3 1/8, how much more do I need to make a unit of 1? So this time it's asking, how do I get from 3 to 4? Because really this is 3 with a little bit extra. I would need 1 plus what will give me 8? 7/8, right? And when I add that 7/8, I get 4. And if I show that with a number line, I start with 3. I'll have 4 since we're getting to that next whole number. These are all about getting to the next whole number. So 3 1/8 is where we start. And to get to 4, I have to add and group. I have to collect all these eighths. 1, 2, 3, 4, 5, 6, 7. I'll draw my arrow to get to 4, and that's plus 7/8. Another way of showing this addition, just so we understand really what's going on, we know that 1/8 plus 7/8 equals 1. If I already have 3, I add those like units, right? We can change eighths to ones, and then if I have 1 plus those 3 ones that I already have, I have 4. So I'm using my understanding of how units work to do that. Okay, so now we're getting used to this pattern of looking at the ones first and then the fraction. The sum of the ones here is just 5. There's no other ones to add. And in this case, it's the 5. The sum of the fourths, if I add 3/4 plus 2/4, I'm going to get 5/4. Now, just to show what's happening here, that can be decomposed. Now, decomposition is what's going to help us do fraction addition. Because really, this has 2 numbers inside of it. It has a 1, 4/4, plus an extra 4th. To show this mathematically, to show what's really happening inside of our numbers and what's going on, I have 5 2/4 plus 3/4, and that equals 5 plus 5/4, since I'm adding that 1 and then the fourths together. And this fourths can be broken up into 1 4/4 and 1 extra 1/4. Since we're adding this anyway, what I'm really saying is I'm breaking this into 2 smaller addition problems. 5 plus 1, which equals 6, plus 1/4. So my answer is 6 1/4. Let's try another one. If I have 7 2/5, the sum of the ones is just 7. So the sum of the fifths, if I have 2/5 plus 4/5, that equals 6/5. And to show what's happening mathematically, I have 7 2/5 plus 4/5. I add the ones first, so I put my 7 down first. I put what these 2/5 added together makes, 6/5. Now I decompose, I break them apart into 1. So this is the same as adding 5/5 and 1/5. I want the top numbers to add up to 6. That's what I'm doing there. Now if I make it my 2 smaller addition problems, 7 plus 1 is 8, plus 1 extra 5th is 8 1/5. Okay, the sum of the ones here. Now this is a problem where I actually have ones that I can add together. So 3 plus 1 is 4. And I apologize for the typo here. If I add the 12ths together, I get 16 12ths. So 5 12ths plus 11 12ths. Notice for each of these problems, I'm never adding the denominators. Those are staying the same. I can only add like units. So if I had changed those numbers on the bottom to say, like in this case, tenths, because I added the 5s together, that's not actually mathematically correct. In order to add unlike units or denominators that are different, you have to do a conversion and multiplication, which we do in 5th grade. But for 4th grade, we're just adding like units. So I just worry about the numerators, the top numbers. So 5 12ths plus 11 12ths equals 16 12ths. And to show what's happening mathematically, I'm going to show it down here just to have a little bit more space. So if I have 3 5 12ths, I'm going to add 1 11 12ths. Remember, I add the ones first. 3 plus 1 is 4, because I'm adding like units, the ones. 3 ones plus 1 ones equals 4. And then if I add the 12ths together, I get 16 12ths. In my mind, eventually I want to do this in my head, I'm going to break out a 1, so 12/12. And I'm going to break out the rest, the amount that I need to get to 16. So first I make the numerator and the denominator match, and then I pull out the number I need to get to that top number, because this is still the same. What we do here is we're just saying that this and this are part of this number. We can decompose them into smaller fractions. Now I have an addition problem where I can say 4 plus 1 equals 5 plus that extra 4/12. Just like that. There's one other method we can use to help us solve these problems. It's called the arrow method. So when you think to yourself, we're going to use the arrow method, and a method is just a way of doing something. Okay, so in my head I'm going to think to myself, what fraction added to 5 2/4 makes the next whole number? So how many fourths do I need to get from 2/4 to 4/4? I need 2/4. And to show that, I'm going to pull out the amount that I need. So I'm going to kind of split this. On one side, I'm going to do the way that we've already done. So 5 2/4. I'm going to be adding 3/4. I need 2 more fourths. Remember, I'm trying to make ones. Ones are the easiest to work with. So I'm going to pull out the 2/4 I need to make this 1, and then the other part that I need, that is just part of this number, 3/4. So if I add 5 2/4 plus 2/4, if I give 2/4 to this, that makes 6, and I have 1/4 left over. An arrow way to show this clearly, instead of drawing a number line, we can draw arrows to show the sum. So all of that, what we're doing here is we're kind of condensing or making that arrow drawing smaller between numbers. It shows the skipping on a number line, but in a more clean way. So I have 5 2/4. So this is that actual arrow way. So 5 2/4, I need to add 2/4 to get to 6. And remember what I'm doing, this part right here is this decomposition of the 3/4, that breaking it apart. So I'm not going to add just crazy numbers. I'm actually breaking up the 3/4 into smaller numbers. And I need that other 1/4 here. I get 6 1/4. For now, I think it's helpful to see both kind of side by side, because they both relate with each other in how they think about, or how we think about adding fractions. So the fraction, I think to myself, what do I need to get 7/8 to be 8/8 out of the 3/8? Well, I need 1/8. So to show that, I have 3 7/8 plus 3/8. On this side, I'm decomposing and pulling out the number I need to make 7/8 8/8. So if I add 1 to 7, I get 8/8. On this side, I'm putting my leftovers. 7/8 plus 1/8 is 1. 3 plus 1 is 4. What I'm doing there is I'm saying 7/8 plus 1/8 equals 8/8, or 1. So if I add these two together, I get 1. And then I add the extra piece over here. The arrow method would be starting with 3 7/8. Then I'm going to pull that number apart. This decomposition is what goes above the arrows. So just that 1/8. That gets me to 4. And then the extras, 2/8. And I'm adding them. So that's 4 2/8. And that's it for lesson 30.